Hello everyone. My name is Dmitry Vostokov. Welcome to the episode 16 in hexadecimal of Debugging TV Frames program. You can type your questions during this episode. If I can't answer particular questions now, I then post answers on the website WinDbg.tv. This episode is about Windows 8 and a debugger update. We briefly discuss topics such as on this list. Our aim is not to give the comprehensive coverage, but a few visible changes and news related to memory dump analysis just after operating system release. It looks like the old debugger cannot read complete memory dumps. It grows in size and hence, although on faster machines, we get finally a message about invalid file format or so. During execution, this system was very sluggish. The new version can be downloaded from DDK or SDK or from WinDbg.org for quick links. I saved a crash dump of an old debugger trying to open a new Windows 8 complete memory dump. So now I open it to show a few commands. So I switch to WinDbg. Already preloaded a crash dump. So we see the new debugger version. This was WinDbg process running. So if we get stack trace collection, we find one thread, the last one, that seems to be stuck in file initialize. Identifying target, reading some file. Actually, this WinDbg grew up to 2 GB in memory. It was trying to load 2 GB complete memory dump. So let's check addresses, virtual memory. We get all memory regions, and we find one region here that is too big. And if we dump its start address, so this is start address, end address, and its size. So you see the size is, actually you see it's 2 GB, more than 2 GB. So let's dump the start address. And we see that memory corresponds to complete memory dump or kernel memory dump header, file header. Also, if we check CPU consumption, we won't see much in user mode for this thread number 14, but it looks like in kernel mode it was consuming the most since the start. But we can open this complete memory dump using the new updated WinDbg. So I already opened for you this complete memory dump. So you see some diagnostics from debugger is a bit new about symbols, some changes. So basically I would like to show you that with the new debugger, the previous shortcut that we used to dump all processes and their thread stack traces is no longer valid. For example, in the past, I recommended to do like process 0ff or complete memory dumps. And this ff parameter covered all flags, including physical to virtual translation and symbol reload. But now, if you do that, you don't get stack traces. So I created log file that I post later on. So if we use this command, it will dump only thread summary. No stack traces. It will also dump usually process environment information as well, but no stack traces. So to get stack traces, you need to be a bit more precise, to use 1f or 1.6 parameters. And if we type this command, we get all these stack traces, but at the same time, we don't get any process environment info. So it's a bit confusing. So now we need probably to elaborate on more detailed commands for stack traces. But usually if you put 1.6, you get stack traces with arguments that are taken from raw stack. So these are small changes with the new update. But at the same time, you may find something new as well. For example, the so-called frozen processes. If you, for example, type command for example, what I do now, I type process 00 to get the list of processes. Oh, that's the wrong dump. 1 second. So we need to type here. And if we scroll a bit, we find a few processes that have deep freeze attribute. These are usually processes that you launch from start page in Windows 8, like Internet Explorer. And then if you switch to desktop, they are made frozen, probably to consume resources for tablets, for ARM CPUs. And if you look at their stack traces, please I think this phase count, you would see that threads for these processes, they also have freeze count as well. Now this is also very similar to a case when we have processes under a debugger, if we have a debugger attached. So when I post this presentation, you can go to this link for this new pattern frozen process that discusses this new feature. The support for abstract patterns can also come from new tools or new commands. For example, there is a new command in new WinDbg version. There are many commands, new commands, but this one is very useful. It's called for each register. And this command, for example, you can execute any command for each register value, for example. Take any dump, for example, Internet Explorer dump, and let's dump for each. We execute commands such as dps, for example, and use this alias. But we specify length 1. But anyway, so this command may be useful for some context. For example, when you do tracing. And some time ago, we introduced the so-called collective pointer concept, where several pointers are combined into one. And so this command now, this concept now acquires a support from this command. So when we execute this command, all CPU execution context registers form a collective pointer pointing to diverse memory regions. So this may be useful, and you can also devise additional uses for such commands. So finally, we have another slide with some changes since last TV episode. And again, this is all for this episode. Thank you for watching. Please later check out the slides and recorded video from debugging.tv. And the next episode will be, I think, not on the 5th of November, but next week, 12th of November, I think. So thank you all for watching, and see you in 2 weeks. Bye-bye.